Now with respect to G, and it said dl by dgt, gt by ug here, and u0 also we need to ot, dl by dot, and dot by du0, and for uf also dl by ft, forget get, then dft by uf, and get xt transpose, something like that for these things. And as I've shown dit by dy, you have got x transpose, something like this. So you just apply those derivatives directly, those are simple, and you will get these results, something like this. And again, these things, whatever over here, these things we have already solved. That's what we are talking about, states and gates. First we need to solve so that it will be easy for us. We need not to recalculate all how we have solved this. For example, dl by dit, how we have solved that. If we just see, so here dl by dit, then again we need to dl by dyt hat, then dyt hat by dht by dct, and then dct by dit, because it is over here with respect to it that we are doing, so we can stop there. So all these steps need not be included. Again over here we have calculated it. Again, if you want to include it, you can include it over here, all this again it will be like simply it will go till ut only, dit by with respect to ut we are doing. So this thing I'm telling, all this thing we need to calculate, we have calculated earlier itself, and so we need not to recalculate again. And dit by dy is over here, and same goes for this also, dlt by dot, dl by dot, dl by dgt, df, dlt by dft. So we have already calculated those, so gt, ot, all those things. So dl by dit, whatever over here, we can just substitute this value, and again it's same, because dl is over here and last is it will be matching, and chain rule, all this chain rule will perform. So if we first only will calculate, means it will be beneficial for us, so that we can simplify the steps. I have written this crisscross, this one is over here and this one is over here. So this is like crisscross, this is over here and this is over here, 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 all those, and whatever the remaining we will get, and that will be is written over here, so that dimension can be shown simplified in a simplified manner. So di by dui is nothing but this thing, xt transpose into it of 1 minus it, and same goes for this also. This one is this, and this one is this multiplied by this one is this multiplied by this. Just shuffle so that this dimensions, everything can be simplified in a simplified manner, we can show for optimization and consistency throughout. And once again like dl by wi, whatever we are getting over dlt by dit, we need to, if we have calculated previously only, here as we have did dlt by dit. So once again this dlt by dit, and again dlt by dgt, dlt by dot, dlt by dft, whatever there. So if we are so calculating u and w, we need to calculate states and gates. So if we have calculated this array, it will be simplified way. We can substitute those. As you can see, we have previously calculated dl by dit, which we are going to substitute over here. That is nothing but dl by dyt, then dyt by dht, and then dht by dct, and in ct we need to stop till it only. So with respect to it we are doing, that's why. So we just dct by dit will do. This whole can be substituted over here. This whole can be substituted over here. That's nothing but over here. And again we get same, because dl is over here and last will be, your denominator will be it. So it will come over here, and it will cancel, and all these are in chain rule. So it doesn't make that much change also. It's just for simplification, we are not showing this entire expression, chain rule expression, as simple this derivative, and we can just substitute that. So that's everything, like gradient with respect to u, w we have seen earlier. So that's how, like, these things will be backpropagated, and all the weights are calculated, and those will be updated by using gradient descent formula for each epochs, and we can stop at certain epochs after some customized value, or we can do early stopping, hyperparameter tuning, all those we can do, so that we can train our model using LSTM also. And again, LSTM is like sequence to sequence, RNN is like a base. Some problems are there in RNN, so we use LSTM architecture, which is beneficial, which solves those problems like gradient, like vanishing gradient, exploding gradient things. And this is a LSTM cell structure where we will be having hidden state, cell state, output will be there, input gate, forward gate, output gate, candidate gate. So states and gates will be there as shown, all those things. So this is pretty much forward and backward propagation of LSTM. Thank you guys.